Okay. Next topic of this unit number 3 for wireless LAN standard is IEEE 802.3. Very, very important. IEEE 802.3. What is the full form of this IEEE? Institute of Electrical and Electronics Engineering. Institute of Electrical and Electronics Engineering. What is the meaning of 802.3? That is the standard which is defined by this IEEE organization. The standard which is defined by this IEEE organization. Where you are using this IEEE 802.3 standard? For the Ethernet. For the Ethernet, we are using this IEEE 802.3 standard. And in this IEEE 802.3 standard, we are using some of the protocols. What is the meaning of Ethernet? The Ethernet is nothing but what? You are seeing the port, Ethernet port at the backside of your laptop. That is called as a Ethernet port. That is called as a Ethernet port. If you want to access any internet from the LAN cable, if you want to access any internet from the LAN cable, that Ethernet port is required. That Ethernet port is required. This Ethernet IEEE 802.3 is mainly working on this Ethernet technology. Ethernet is, this is a hardware part. This is a physical device. It is a wired device. It is a cable. We are using the cable, Ethernet cable. It is not working on the wireless. It is working on the wired, that is of cable. We are using different cables for connectivity of this internet. You have seen the different cables. If the server is broad, we are using different cables. If the server is less, okay. For small organizations, we are using some of the cables. For a smaller organization, we are using the medium cables. If you want to provide the worldwide, that is for a longer distance communication, we are using more and more cables, Ethernet cables. So that is what we are using a standard, that is IEEE 802.3. This IEEE 802.3 is using the LAN cables. Though we are using the LAN cables, we are using also used for metropolitan and the wide area network. Metropolitan area network also, and for the wide area network. For the connectivity, for the better connectivity, we are using Ethernet. What is the main advantages of the Ethernet? We are not using this wireless. We are using the wired. We are using the telephones. The previous years, from last 15 years back, we have used a telephones at our home. What is that connectivity? Is that telephone is wireless? No, the telephone is wired. The particular cable is connected from our telephone to the particular server destination, telephone cable. Okay, that internet, what is happening in that particular device? Whatever the voice is there, that voice is very clear, very clear. There should not be any noise is going to interfere in that particular noise. So we are hearing that noise particularly very clear voice, we can going to hear that. So there is no disturbance has been happens. Whatever the signal is going, whatever the frequency band is going in that particular cable itself, it is not moving in the air. It is passing through that particular cable itself. So whatever the data is there, that data is authenticate, that data is efficient, will get the more efficient data at the particular destination. We can hear a clear voice while we are speaking to the another person, that person is also listening that particular voice very clearly. So this, if we are using Ethernet, only one disadvantage is that it takes a delay. What we can do for this is, why it is going to take the delay is nothing but we require a longer cable. It is, this Ethernet cables can be used for shorter distance communication. The Ethernet cables can be used for shorter distance communication, not for a longer distance communication. If you are using for a longer distance communication, it requires a time. It requires a time. So Ethernet technologies can mainly define for a shorter distance communication. For this Ethernet technology, we are connecting the metropolitan and the wide area networks. We are connecting by using this Ethernet. We are going to connect the metropolitan area networks and even the wide area networks. So this is working on the physical layer. IEEE 802.3 is working on the Ethernet, and this is going to define as a physical layer, not a logical layer. Physical is you are seeing that particular device. You are seeing that particular device, that is called as physical. What is logical? You can't see that particular, you can't set that particular device, that is called as a logical. A particular person is seeing, you can see that particular person from outside itself. By seeing that body, you can see that particular, you can imagine that person, that this person is this one. How can you came to know that what is going on inside that mind, inside his mind? That is called as logical. So IEEE 802.3 is working on this Ethernet, that is on a physical devices. So this physical layer is going to use for media access control as a sub layer for wired Ethernet networks. For a connectivity of this wired Ethernet networks, we are going to use this. You are taking the help of this second layer, that is data link layer, that is media access control. Media access control. So what are the popular versions we are using in Ethernet? Different cables we are started using this. The first cable is of IEEE 802.3, and this cable is, the name has been given for this cable is 10 base 5. That is a original standard, that is IEEE 802.3. The name has been given for this 802.3 as 10 base 5. What is the meaning of this 10 base 5? 10 is nothing but the speed of particular data. How much the speed, how much data it is going to carry. The speed of this particular data to carry is of 10 Mbps. Base is nothing but it is going to carry the baseband transmission, baseband signal. I'm give the concentration on this. The 10 base 5, the different Ethernet ports, different Ethernet cables we are using in this. So 10 base 5 stands for, the 10 is nothing but the speed of that particular data, the speed of that particular cable, that is a 10 Mbps. Base stands for baseband transmission, and the 5 stands for how much is the length we can use, how much is the distance we can transfer, that is 5 millimeter or 500 millimeter. So very long, shorter distance communication we can use this particular cable 10 base 5. This is the original standard Ethernet cable we have started using. This is called as a thick single coaxial cables. This is very much thick. Broaders, I think you have seen at the childhood age when they started installing the telephone in your home, they started digging the earth. After digging the earth, they started installing the cables, the black cable, which is very broad, which is very thick. That thick single cable, coaxial cable can be used for this, initially for a telephone. And this connection can be giving by drilling into the cable, into the core. So you can remember this, the IEEE 802.3, the original standard cable is 10 base 5. 10 stands for the speed of particular data, that is 10 Mbps. Base stands for, that is a baseband transmission. We are going to use the baseband transmission, and 5 refers to the distance or the length of this 500 millimeter. And after this coaxial cable, if you are started using the thick cables, and technology has goes on, changes, and started using IEEE 802.3a. The versions are started, the different versions we have started using. Everything will be called as a coaxial cables itself. Everything will be called as a cables, Ethernet cables, but we are using different names. IEEE 802.3a, that is called as 10 base 2. 10 base 2. It is going to use a BNC connectors. Have you seen the BNC connectors? Have you seen the, just see the BNC connection. Just type in the Google the PNC connectors. You have every day in the some places you have used this BNC connectors. Okay, these BNC connectors can be used for this. That BNC connectors is called as a 10 base 2. 10 base 2 is nothing but a very less distances we are using, but the cable is very thinner. Cable is very thinner. That is of IEEE 802.3. The thin cables we are using, variety of cables are using, and these cables and these coaxial cables are connected by the coaxial cables, that is BNC connectors. Just type in a Google, you can see the image of this BNC connector. I think you have seen those BNC connectors in day-to-day life. That is called as a BNC connectors, can be carried as these cables are going to connect to the BNC cables. And what is this length? 200 meters. Okay, not more than 200 meters, that is less than 200 meters we can use this BNC connectors. This is the second version of IEEE 802.3. And next version, that is IEEE 802.3i. IEEE 802.3i. This is called as a twisted pair. Twisted pair is nothing but outside the cable, outside that cable, inside some of the wires are connected. One is red, blue, green, yellow. I think you have seen that cable. Once you cut that cable, inside that cable, you are seeing the different wires, color wires. That is red, blue, green, yellow, everything. So that those cables is used as a twisted pair cables. The combination of two or more cables. The combination of two or more cables has to be used in this IEEE 802.3i. The twisted pair cables can be given as 10 base T. And many more cables we are going to combine by using this IEEE 802.3i. This is one of the standard we are using, that is 10 base T, and this you are using to use unshielded twisted pair. And different varieties and different variations we are going to see in this IEEE 802.3i. Which are those variations? That is nothing but 802.3u for 100 base transmission, that is TX, 100 base T4, 100 base FX. These are some of the variations. These are some of the sub versions we are going to see in this IEEE 802.3i. We are going to use the twisted pair cables, copper wires. We can call as a copper wires. Inside that particular Ethernet cable, once you cut that particular Ethernet cable, you are going to see the different wires, different color wires. Those color wires are called as a twisted pair wires. Those wires are called as a twisted pair copper wires. And in those twisted pair copper wires and different connections we are going to give 100 base TX. That is the speed is of 100 Mbps with the baseband transmission. That is called as different variations we have started using, that is IEEE 802.3i. Next, IEEE 802.3i, the one more Ethernet fiber cables we have started using, that is 10 base F, the larger for a high Ethernet, that for a high speed, for this 4G and 5G connectivity, for this 4G and 5G connectivity, for high speed, we have started using this 10 base F. Okay, and in the diagram, you are seeing this diagram, that is IEEE 802.3. Different Ethernet cables we have seen in this. Okay, and different versions of Ethernet we are seeing. That is IEEE 802.3, 802.3A, 802.3I, 802.3J. Last one is J, not I. And this, what cable we are using? 10 base 5 cable. 10 is stands for the speed of particular cable, that is 10 Mbps baseband transmission with a distance or a length of 500 millimeter. Similarly for A, the speed is same. It is also carrying the baseband transmission and the length or distance is less. This one speed is same, and we are going to combine 2 or more cables over here. That is called as a twisted pair cables, and which is used for a transmission purposes. And this is for J, same speed with the baseband transmission for little bit higher distances. And if you are using this different versions of 802.3, we are going to use a different topologies in this particular versions, in this particular Ethernet cables. Which are those topologies, and what is the cable we are started using in this? So in this IEEE 802.3, we are using the bus topology. We are using bus topology. If you are using bus topology, the coaxial cable is thick. The cable of this coaxial cable is thick. It has been introduced in the year 1983. This one has been introduced in the year 1983. Similarly, for this 802.3A, the same technology we are using, that is the thin coaxial cables we are using. We have started using the thin coaxial cables, and it is going to implement in the year 1985. And next, 802.3I, we are using the technology that is topology, star topology. What is the difference between bus topology and star topology? Bus topology is the what? The one cable is common for all the computers. The cable is common for all the computer. Through that cable, we are going to connect multiple number of computers. That is bus topology. What is star topology? Star, it is looking like a star. For one main switch or one main hub, we are going to connect like a star. Like a star, it is going to, star topology is very, very important. Nowadays, we are using a star topology. We are using the star topology now, nowadays. We are using UTP, that is unshielded twisted pair cables. The twisted pair cables we are using in the star topology, that is to be implemented in the year 1990. Similarly, for upgradation, same star topology has been used, started using fiber optic cables or coaxial cables in the year 1993. It is going to be used in the year, started implement in the year 1993. So this is some of the versions of Ethernet for IEEE 802.3. Which are the different types of Ethernets? So this, you have to know the fast Ethernet we can use, gigabytes Ethernets, 10 gigabyte Ethernet, and the switch Ethernet. Fast Ethernet is nothing but how much is the fast for this particular Ethernet, how you are using for receiving and transferring and receiving the particular data. We are using the twisted pair. For the fast Ethernet, we are using twisted pair, that is called as a Cat5 cable. Cat5 cable can be used for 3G system. Cat5 cable can be used for 3G technology, and Cat6, Cat7, Cat8, we are using 4G and 5G. Cat7 can be used for 5G technology. Remember this. Cable can be used for 5G technology is Cat7. Just type in a Google, you'll come to know what is this Cat, where you are using, in which technology we are using. everything you will came to know. Okay, it is started using the twisted pair and with the cable of cat5. And what is the main functionality of this fast ethernet? It is the potential is very high. This, by using this potential, we can receive and transfer the data using around the speed is of 100 mbps, around the speed is of 100 mbps, and it is going to function as a 10 base 100 mbps or a 10 base mbps. 100 mbps is nothing but the speed is 100 mbps. It is going to carry the baseband transmission, and this ethernet can be used for cameras, for connecting the cameras, and for the laptops and other connected to the network. Your, for a small size photo, for ID proof photo, you are visiting for a particular shop to take the photographs. At that time, you can see the particular cable. That particular cable is called as what? Cat5 cable. Cat5 cable that can be used for connectivity of this camera, that can be used for connectivity of this laptop, everything. And this combination of fiber optic cable and twisted pair cable, combination of fiber optic cables and twisted pair cables can be used for increasing, for doing the increase in the particular speed of that particular ethernet, can be used for a fast ethernet to create communication. Which are those some of the examples he has given for the fast ethernet? That is nothing but the 100 base TX, 100 base FX, and 100 base T4. Some of these are some of the categories can be comes under this fast ethernet. Versions are there. These versions are going to carry for some of the distances. 100 base TX is for some distance. To increase a little bit distances, we have started using FX, and to increase the much more distances and started using T4. These are some of the categories can be comes under this fast ethernet. And next, second one is gigabit ethernet. Gigabit ethernet is nothing but what? Giga is nothing but the speed, ethernet speed. It has been upgraded for fast ethernet. Again, they started using the fiber optic cables with the twisted pair cables. Combination of these two cables and to create the communications. You can transfer and receive the data in terms of in the speed of 1000 mbps or a 1 gigabits per second. The speed of this particular data, the speed of this particular cable, or to transfer and receive the particular data in terms of 100,000 mbps or 1 gigabits per second. And nowadays we are using this gigabits ethernets. We have started using gigabit ethernets for this 5G also. For this 5G, we are using the network type as Cat5, that is Cat6, Cat7. This Ethernet is a combination of both fiber optic cables and the twisted pair cables. It can transfer more than a speed is of 10 gigabits per second also, if the combination of both twisted pair cables and fiber optic cables. And the next type of this Ethernet network is 10 gigabit. Same explanation, but he has mentioned the 10 gigabits per second. Nothing but what? 10,000. 10,000. It becomes 10,000. So 10 gigabits in a percentage, in a fraction of seconds. In a fraction of seconds, your data has been reached to the particular person. Your data has been reached to the particular destination. That has to be used in this 10 gigabit Ethernet. 10 gigabit Ethernet. So 10 gigabit Ethernet is nothing but we are sending the data in a fraction of second. It is not going to take a fraction of second also. A 0.001 also. In that speed it's working. This Ethernet is working. In that speed, this Ethernet is working. And mainly We are using the Cat6 and Cat7 twisted pairs in 5G technology. In 5G technology, we have started using the Cat6 and Cat7 twisted pairs. It is a combination of both fiber optic cables and twisted pair cables. We can extend up to 10,000 meters. These cables can be extended up to 10,000 meters we for elfing using the fiber optics viewers. Next is switch Ethernet. What is the meaning of switch? Switch is nothing but what? Networks is going to involve the switch and the hubs. Why they are involved the switch and hub? If you involve a particular server at that particular port, at that particular department, so there is no need to use the a maximum length of cable. You can use only one cable. That cable can be divided into particular switch or the hub, and that hub is going to provide the particular network to the many number of computers. So they are started using this. This is expandable. Ethernet can be expandable at the workstation, at the organization, at the institutes. Means what? What is the meaning of this? Adding the switch or hubs in a particular Ethernet is nothing but the switches or hubs can be provided at that particular device, and that can be installed at that particular department, and that switches and hubs are going to take care of that particular department. How many computers are there? So if there are 100 to 200 computers, the switches or hubs are going to provide only 100 to 200 computers itself, so that the dedicated connections has been given to the particular hub or a switches to the particular computer. So you can broadcast the every information, all the information to that particular device itself. So no need to carry all the cables at a particular computer. Just you have to install the particular, add the particular switch or hubs in that particular device. It is going to improve the particular networks. You can get a particular network. Okay, that is what we have started using the Ethernet. If you're adding the switches or hubs, it is going to improve the network throughput as each workstation in this network can have its own dedicated 10 Mbps connection instead of sharing the medium. And if you are providing the particular network, if you are providing the particular speed to that particular server, it is going to maintain that particular speed itself. If the server is down at the main level, at that time itself, the server will become down at this particular server. So this is what we have started using the switches, and it is latest Ethernets will support the distance or the speed is of 1000 Mbps to 10 gigabits per second. See the speed of this, 10 gigabits per second, more than 5G. 5G is of 5 gigabits per second. If you are moving to the 6G, that is the speed is move from 5G to 10 gigabits per second. So this type of Ethernets is going to provide the maximum efficiency, maximum throughputs. Okay. And what is the frame format of this IEEE 802.3? The frame format is this one. One is preamble. The second one is start of this particular data, source address, destination address, what is the length of that particular data, and you have to check that data with panning, and you have to check finally at the if there is error or if there is no error, that is cyclic redundancy check. How many bytes? Preamble is nothing but what? Preamble is going to alert the particular block to the next block that I'm sending the particular data. So start receive that particular data. That is going to send only the alert to the next block. Okay, it is going to send the alert or timing pulses. Once alert has been given, it is going to add ones and zeros. Ones and zeros. Why are you going to add this ones and zeros? The particular destination, a particular receiver is came to know that yes, the particular data or the packet has starting from this. Yes, it has been starting from this if you're adding the particular preamble at the initial stage, ones and zeros at the initial and at the end. And we are going to write the source address and destination address, and the source is consist of 6 byte and destination is consist of 6 byte. After adding this two, it has to be decided by the length. How much is the length has to be decided. Minimum and the maximum length. Minimum length is nothing but what? If the minimum length is 64, maximum length is 64, we can send up to 64 bytes itself. Up to 64, the fixed. We are saying, I'm telling you the fixed length. The maximum length of this packet is 64. You can send up to 64 itself, not more than that. Less than 64, that is okay. Not more than 64 bytes. That is to be using. And this is minimum, I am telling. The maximum length of data we can send is 1500 bytes. Minimum is of 64 and a maximum is of 1500 bytes. And this is combination of both data plus padding. Once data has been received at the particular destination and the receiver, and it is to be checked by this one of the flow control method, that is cyclic redundancy check. This is one of the flow control method. This is going to check whether there is an error or there is not an error. There will be error in the particular data. It has to be detect and make it correct. If there is no error, immediately that data has been received at the particular receiver. This is one of the frame length. The frame structure has been decided for this Ethernet. The frame structure has been decided for this Ethernet. And the next topic is advantages of Ethernet. What are the advantages? I already told you the advantages of Ethernet is better efficiency, good work, it has to be done, high security has to be maintained, a quality, the network quality is good, and we can maintain by using the administration. By administration can be control everything by sitting at one place, and the maintenance is very easy. The administrator is came to know that where the maintenance, where the cable has been disconnected, that is to be lost. So that has to be maintained at the particular instant of time. And speed, we can going to increase the particular speed, that is from 1 to 100 Gbps for connecting the one cable to the another cable. And different versions of Ethernet we are using for increasing the speed of that particular data to carry the data from one location to another location. So main important advantage of this Ethernet is high security. We are not sending the data in the air, that is wireless. We are not sending the data in the air, through air. It can take any route to reach the destination, but in this Ethernet, in this wired connection, it is not going to happen. At that particular connectivity, at that particular destination, dedicated cable itself, that data has to be reached to the particular destination. This is what Ethernet is going to do. But in internet, you're using Wi-Fi, Bluetooth, and hotspot. This is not secure. Anyone can access your data. This is not secure. That is wireless. We are doing this. So these are the one of the advantages of Ethernet. What are the disadvantages? Whatever the data we are sending, that data cannot be reached at the particular time. So it takes a little bit time to reach the particular destination. So the one by one, it has to be carried out. It has to wait for some amount of time. Once that data has been reached, next data you have to send. So it takes a time. So it is short. It should not be reached at a real time. That is one of the disadvantage. And you have to connect the different cables, and you need different devices. That is like cables we need required, hubs we required, switches we required, routers we required. It is going to increase the cost. It is going to increase the cost. That is one of the disadvantage. And one more disadvantage is main important is distance. We can't increase the distance immediately. It is restrict for some of the distances, short distances. For better connectivity, for high security, For efficiency, for good network, it is to be working on only short distances, not for a longer distances. One more disadvantage is we are not getting any acknowledgement back. We are not getting any acknowledgement for this Ethernet. And it is not secure. If you are using wireless network, it is not secure, and comparing with the wired. And while working on this Ethernet system, we require some of the experience for in the network feed. In the network feed, we require some of the experience while installing this Ethernet. So these are some of the advantages and disadvantages of Ethernet. So today we have seen the second IEEE, that is IEEE 802.3. This IEEE 802.3 is mainly working on the Ethernet. Ethernet is nothing but a different versions of cables we have started using. So those cables are going to provide the particular speed. How much is the speed? That has to be decided by this particular Ethernet. Okay, we'll stop here.